Hi, my name is Nicholas, and I'm a second-year PhD student at CSAIL in the robot locomotion group. My research mainly focuses on creating realistic and large-scale simulation environments for robotic manipulation. So right now, the goal in robotics is really to train a generalist model, basically pre-training it on large-scale data, similar to how we do it for large language models such as ChatGPT, for example. And the big issue for robotics is collecting a large-scale training data. And doing that in the real world is tedious. You would have a robot, a human maybe showing the robot how to do something, but really scaling this to a scale that is similar to the whole internet is almost impossible. So my research is really focused on creating realistic environments in simulation that we can use to collect this robot training data, or also to evaluate robots in. For that, I was just finished up 2 projects in that direction. The first one was focused on creating realistic assets for objects that we can use in our simulators. So for that, I created a robot system that could pick up any object and move it a bit around and then identify its entire representation. So its geometry, its visual appearance, its physical properties. And then once we have these assets, then the second project was really focused on how do we arrange them naturally in simulation so that they represent real-world distributions of environments. And in order to create such a robotic system, the way we know how to do it is to create large-scale data that we can then replicate. And for that, we first have to give this data to the robot. Usually, this works by demonstrating a task and then having the robot duplicate that task. But if you want to demonstrate everything that could ever happen in the real world, then that takes a lot of data. And my research is really focused on how can we provide such large-scale data, but without having to manually interact with those robots in the real world, which just will never get us to this data scale that we would need. Having a generalist policy allows you to achieve an extraordinary sense of robustness. If you're developing a specialist, you're always these are my rules that my domain should be within. The moment I leave that environment, maybe someone throws some real weird item in a basket, or I drop something and it ends up exploding. When I was working at Ocado, we often had okay, I pierced the milk bottle. Now there's milk all over my workspace. There's no pick-and-place system that can basically clean that up. You would always have a human that would have to come in. But if you maybe start with a generalist policy, now you're suddenly robust to these things. You have experience dealing with those rare situations. So currently actually my philosophy is that we should have a generalist robot first, and then we should specialize the generalist robot. So for example, again, taking the large language model analogy, people first they pre-train on all of this data. They have a model that can answer general questions. And then you do something that's called reinforcement learning, fine-tuning, where you then specialize that model more. Maybe you say, okay, it's a thinking model, it is really good at doing math. Maybe it's really good at doing coding. But at the same time, you really needed this generalist in the beginning in order to have this robustness to all of the disturbances that you might face while working on the specialized task. One of the unique aspects of being a graduate student or just working in academia is really that you're able to really focus on the big goals of the field. So you can think about how do we see the field of robotics to go in the next decade, the next 2 decades, the next 3 decades? And how do I think I can contribute towards that direction? CSAIL is actually an amazing place to do research in. Initially actually came here as part of an exchange program to finish my master's, and I've really been falling in love with the place since. All of the people here are just extremely clever, extremely open to collaborate, extremely open to talk about random ideas, maybe give you feedback, think about high-level things that are going to happen in 10 years, but also things that are really detailed. Okay, how exactly am I going to optimize this code so it's fast enough to run real-time on a robot? And this environment is just amazing to do your PhD in.